there. And I have to be differentiable on the open. Well, let's look at the derivative. No restrictions on the derivative, so we're good there. So the mean value theorem can be applied. And in fact, what does the mean value theorem say? That there's going to be some c belonging to the open interval from -1 to 1, where f prime of c equals that f of b minus f of a over b minus a. Okay, so let's go do that now. So that was just checking off the conditions. So let's see, what is f of b minus f of a over, b minus a. Okay, so let's plug in 1 here. 1 minus 1 is 0, so I have -2. Let's plug in -1. -1 minus another 1 minus 2, and then plus 2. Oh, is that 0? I don't know, I'm just checking my -1, and then plus 1, and then plus 2. Oh my gosh, that's 2. Okay, over over 2. Can we just redo this one really quick? Okay, let me just show my work. Maybe that will help. So f of 1 is going to be 1 minus 1 minus 2, which is going to be, those cancel, I have -2. F of -1 is going to be -1 minus 1 plus 2, which is 0. Okay, I was good. So this guy is going to be f of 1, -2 minus 0. Okay, so that gives me -1 for my secant slope. So then I know that I can set -1 equal to the derivative to go find what x would be. So that is my f of b minus f of a. And this is my f prime of c, and so I'm setting them equal. So now I want to solve, so we're going to use our Algebra 1 skills, if I can do that right. Alright, so add 1, so that's -1. Go ahead and factor that. If factorable, if not, we'll have to use our quadratic formula. Okay, so let's see, that'd be 3x, I'm going to have 1 and 1. If I want a -2, that one's minus, that one's plus. Okay, so x is going to be 1 and -1/3. So, what are the values where this exists? Well, it has to be, C has to belong on the open. This is so tricky. It's like, I'm going to try to trick you because I just gave you a value of C, and it's on the closed, but not on the open. It just misses it. So the only C that I'm going to take is at -1/3. Be careful, because I'll probably try to trick you like that on the test. Okay, so let's just kind of look at the graph again. Not again, but for the first time. So that was x times x squared minus x minus 2. And we'll zoom standard first. See what we want to do. I'm looking from -1 to 1, so I'll probably zoom in. Ooh, this guy's taking a while to think. Why are you taking so long? It's just quadratic equation. Okay, let's go back. Maybe if I just type it in where I distributed. Okay, So let's kind of zoom in a little bit between -1 and 1. So if I look at the slope between where -1 and 1 is going to be, it looks about like that. So if I continue now, I should get one more little paper clip, huh? So you can really see it. Oh, here's a smaller one. I like that one better. So you can really see what we're saying. So there's your slope of your secant between -1 and 1. And if I kind of am taking along as I follow this curve, it looks like about right there is when I'm going to have the same slope going on. And that value is at -1/3. Woohoo! That's the mean value theorem. Alright, so this is a pretty cool one. A car is going to leave a toll booth on I-70. So here's my little car. He's going to leave the toll booth and he's going to travel. 15 minutes later, so we'll call this time 0, and we'll call this time 15 minutes. And he is 20 miles down the road. He is clocked by a state trooper. Ooh, that poor guy. He's got. Okay, so he's clocked by the state trooper at 70 miles per hour. Oh, per hour and minutes. That's not good. What do you want to do here? You want to convert that? Okay, because we don't want hours and minutes. So let's see, 15 minutes is 15 over 60 hours, which would be 1, 2, 3, 4, 1/4 an hour. Okay. So it says, prove that the driver of the car exceeded the 70 miles per hour speed limit at some time between leaving the toll booth and being clocked by the officer. Okay, so if I talk about this miles over hours, and I'm thinking the average rate of change versus that instantaneous rate of change, I want to show that at some point instantaneously that he was over 70 miles per hour. Okay? So if I look at the instantaneous part and the average part, I'm thinking, gosh, instantaneous versus average, mean value theorem. So my mean value theorem says, well, am I continuous on the closed interval? So on this closed interval, am I continuous? From what, time 0 to time 1/4? Yeah, I mean, he's driving, he's going. He's continuous. You just kind of have to assume that. Am I differentiable on the open? Well, let's just assume he's not doing any loop-de-loos or anything like that along the way, and he's just driving along a highway road, a normal highway road. Sure, that's differentiable. Okay, there's no like inroads or anything like that. Okay, so now that these are met, we're going to say that f of b minus f of a over b minus a is going to equal some f prime of c. Well, let's go find that f of b minus f of a over b minus a. So let's see, at my 0 and 1/4. So let's see, f of 1/4, I am 20 miles down the road. Remember, we're miles over hours. Okay. So these are my outputs. These are my inputs. Okay. Maybe it helps to say the time down here first that I'm going to use, my b minus my a. So f of b minus f of a. So at time 0, I was 0 miles. At time 1/4, I was 20 miles, which would give me 20 over 1/4, which would give me 80 miles per hour. Okay, so that's the average that he was driving. So that's the average miles per hour. Okay? So, by the mean value theorem, there is some time between the hours of 0 to 1/4 such that his instantaneous velocity equals 80 miles per hour. Pretty dang cool. Now you can go be a policeman and be like, hey, you only went so far. Okay, so this is the thing. Like, let's say you get this little ticket and they give you the time, and then you're going to have to go pay, and you clock in with another time, and they know that distance. That's a set distance. So you can get a ticket just from going between one toll booth to the other by looking at the time, because you have a set distance, right? So if you have the change in the time, and then you have this distance that's set, and you just put in the time, you can see your average rate of change here. So if that average rate of change, if that average rate of change exceeds the speed limit, you've sped at some point, you get a ticket. Well, yeah. Okay. So that's the end of those notes, and I will see you guys later.